So one of the first questions you had to answer was, how do you roll a ball down a hallway? Most of us take this simple skill for granted, but it's much more complex than that. So let's begin our discussion on human motion, reviewing what does it take to even roll a ball down a hallway only looking at the upper extremity.
So let's take a look at this motion first from the frontal view. From this frontal view, we can see that rolling the ball is a sagittal plane motion, including flexion and extension of the joints. In its most basic movements, we start in the anatomical position. And what we're going to do is focus on what the upper extremity is doing during this motion. The upper extremity includes the shoulder joint, elbow joint, and wrist joint. In this position, the forearm is supinated, the elbow is already extended, the shoulder is in a neutral position. The first motion is the cocking motion, and that includes sending the shoulder into hyperextension beyond normal. Once we reach the end range of motion, we then reverse course, and the shoulder slowly comes into a flexed position. The ball is released, the elbow is flexed, and the wrist is flexed all the way through the follow-through. Now let's take a look at the lateral view of the same motion, but this time we're going to add a little bit of preparatory movement. In this vision, what you will see is that the elbow moves into a flexed position from the anatomical position to start the motion. From here, the cocking phase will resume, the elbow will extend into neutral, as the shoulder is also hyperextending in order to prepare for the roll. Let's move back into our frontal view, but this time we're going to talk about what happens from the hand. At first, in order to grip the ball, we move the wrist into flexion, we abduct the fingers. Once the ball is placed into the hand, the fingers flex and the thumb abducts and opposes. The elbow moves into that flexed position. The shoulder becomes extended into the cocking phase. The shoulder flexes, followed by elbow flexion after the ball release in order to get that ball to roll straight ahead. Let's look now at a lateral view. Watch closely, as in order to prepare the ball from the anatomical position, the wrist goes into a flexed position, and the fingers, while still abducted at this point, once they receive the ball, the fingers will actually begin to flex and the thumb will begin to oppose in order to grab that ball and hold it in the hand. The elbow moves into a flexed position in order to prepare for rolling the ball in a straight path ahead of the body. Following this elbow flexion, the shoulder moves into extension and then hyperextension. The elbow becomes extended, and if we watch here, the wrist actually moves into a slightly extended position. The shoulder flexes, the elbow is flexed, the fingers open up and extend, the ball is released, and the elbow moves back into a flexed position. So in summary, when we talk about the kinematic assessment of rolling a ball with the upper extremity, remember, always start in the anatomic position. In order to grip the ball, we use wrist flexion, finger flexion, thumb flexion, and opposition. The elbow flexes in order to prepare for the motion. The shoulder then moves into a hyperextension. This is beyond the neutral anatomical starting point. To start the motion, the shoulder flexes, the elbow flexes, the fingers and the thumb extend, and the ball is released forward and straight. As for the next steps with this kinematic assessment, what you want to do is now identify what muscles are being used to cause each of these movements. And in those individual muscles, are they contracting concentrically, eccentrically, or isometrically? You should be familiar with all three terms already. What nerves are responsible for driving these muscular contractions? Then let's expand the picture. This was a simple assignment looking at only one appendage. What happens when we involve the legs to really add some power behind our roll? What's going on the opposite side? And then, if we completely change this around, how much more complex does it become if this becomes an overhand throw? Hopefully by the end of the course, you'll be able to understand and describe the answers to all of these questions and more for even more complex motions.